Someone was asking for more homework or doing more homework corrections. I'm not sure what that is, but I can give you more homework, no problem. Consider it done. Okay, so here we go. Cosine law, for the most part, you got this right. Some things to watch out for is notation. If you have inverse here, I shouldn't be seeing cosine of A anymore. As soon as you do the inverse, you're technically doing the inverse of both sides. It's just like taking the square root of both sides. The square drops on the left side, right, on the variable. Same with cosine inverse, cosine drops. So that's your answer. It ended up being out of 29, the whole thing. This bottom part here, you just had to solve for the other angles. So you got 2 marks for figuring out one of them, which you had to use sine law or cosine law to do that. And then 1 mark for figuring out the third angle. So this is the combo you got regardless of what method you used. And if you made a small mistake, you show me all the work and something is wrong, you lose half, okay? Next, the word problems. What I'm going to say here when it comes to word problems, make sure you don't mix up triangles, okay? Some of you are, this is hard to see, but this is 59 because I use this triangle here. So that take away 31 and 90 from 180, get 59. And this one up here is 48. So a lot of you went sine of 48 over 24, and then you went sine 11 to figure out this. They're different triangles, right? The 48 and the 24, you're looking at this big triangle, so you cannot use the 11 because that's just this triangle right here. So don't mix up triangles. Be careful to stick within the triangle you're working with. Okay? Honestly, this one had so many different ways of solving it. I was amazed how many ways students solved this, right? So some of you figured out the whole thing, the height of the entire, like the building and the sign. You figured out that, and then you figured out this smaller triangle, this triangle here at the base. You subtracted these to get that. All of that worked out. If you did that correctly, you got 719 feet. So regardless of how you did it, I went the route of sine of 59 over 24. So 59 over 24. And then I used the 90 to figure out y. Okay? And as soon as you figure out y, this is the one they share. Now you have a pair here, 48 over y, and 11 across from this little stretch here. So that's how I solved it, but you know what? You do whatever you need to do, and some of you even took the time to redraw this, because this was very, very busy. I agree that this was a bit too dark. I should have made it a little lighter, but good for you. Do that. If that helps you, redraw, sketch it, and then you go for it. This one, you know what? I was overall very, very pleased with it, but some of you forgot or you didn't see this. And maybe because you were like, oh yeah, I remember this from the notes. So this is just right there on either end of the helicopter. You got to read carefully. You might come across some that look like the ones you have in your textbook. All I have to do is add a little twist to it and it becomes a different question, right? So this is where the helicopter is here, and I believe I redrew it for everyone if you made a mistake. So you have the little diagram there. You're welcome. And also make sure your angle of depression is measured from the horizontal, right? You can't just go from the vertical up. That's going to be a wrong diagram, so you lost marks there. How did I approach this? Me in particular, I went sine of 62 over 400. Where's the 62 coming from? This 62 here, alternate interior, right, comes in here. So I have my pair there, and then I go sine of 90 over x, okay? And that's what it's asking for, like the direct distance of the helicopter to the collision. I also was hoping that you would know that the collision is further, like closer to the helicopter because it has a greater angle of depression, right? You're going, right, you're tilting down further, so that means it's closer to you and the ambulance is out here. My approach is always when there's multiple triangles, I find a side that they share, okay? These triangles, so that's the one, and I kind of prompted you to do that anyways. And now you have another pair, sine of 27 across the side you just found, and 35, I got 35 by subtracting the 2 angle of depression to give me that one. So that's y right there. And that was the next distance that I had to find. If you drew it the other way where the helicopter is in between these two, I made a little note up here, you should get 997.73. So you get the same direct distance to the collision, but your distance like between them is obviously greater, right? So you get 997.73 there. So overall, I was still happy even though you misread it. Whatever follows after your interpretation is what matters. Unless it causes you to do a lot less work, then you lose more marks. All right, over here, I believe this one is straight from the notes. I believe so. Maybe a little different, but right, you're going south 15 west here. So the 15 is right there. And then you're going west 10 degrees south. So this is the scenario, and you have to be a little bit aware of angles, right? So 15 is not a big angle, so it shouldn't be going this way. It should be kind of going further this way. And then 10 degrees off of the west line, you're going this way. Okay? So this 10 and the 15 comes in here in this little wedge, and the 90. So if you go 10, 90, and 15, some of you had that, but you added it wrong. I felt bad for you. You only lost half a mark usually when I saw clearly that you have the 3 there. So that's 115, and that's just simply cosine law, and you get 20.27 kilometers there. And then the one that was a lot more work than what you had originally thought. And just focus there. So here's your diagram, right? You start here, and you go north 25 degrees east. So you're going this way to T, right? Where they turned, put letters there, and then you're going south 51 east. You're going this way. And so the 51 is kind of a partial angle here. This 25 comes in there, and you get your 76. Some of you said, hey, this is 65. And that's not true. This is not 65 because we're not told that your destination is due east of where you started, right? If you actually could say that you're exactly lined up with the east-west line, then yes, this turns into 65. But you don't even need that, right? You have everything you need at this point because you have a pair. This is a solvable triangle. So pair, and then 45 allows you to find angle D, which is the very first thing I do. Once you have angle D, you can find angle H, this angle that you want, because it's asking you for the second leg of the trip. Okay, so once you have H, you do another sine law. You could have done cosine law, I guess, because you have SAS here, but then you figure out this distance, which is 7187 kilometers. And because it's departing here and then turns and then gets to the destination, it's only these two stretches that need to be added. And some of you added the 75. I only took off half a mark today, this time, so be careful there. But this is the total distance for C. This is the from T to D, that little distance here, from the turn to the destination. And then question 2 is a blast from the past, right? A little bit of converting. So regardless, you had to do some sort of conversion. Either you converted your distance to miles, or I turned my speed, 160 miles per hour, I turned that into kilometers per hour. So you get a mark for the conversion. At that point, I'm not converting anymore. I want to know how long would it take to travel that distance, right? This one here. So I went my speed in kilometers for 1 hour. This is the distance I need to travel over X. So you know you need to multiply by 1 and divide by the speed, essentially. So you get 0.4538 hours. If you added 75 to the mix here, you get 0.75 hours, but this is really what I'm after. Okay, 0.45 if you round it. If you did it in minutes, it's 27.23 minutes, but I didn't ask for it, so we're just going to ignore that. Hours is all I needed there. Okay, so that is the quiz. Overall, I think you're doing okay. Just maybe need to spend a bit more time on the compass directions in particular. just word problems, okay? I will be giving you 2 handouts. One handout is multiple choice. I used it as a quiz way back in COVID days, but I'm just going to give you that one. It's actually pretty good. You have a little bit of room to do the work and then select the right answer. I will post the answer key to that. And there's another old quiz from 2018, I believe, 17, 18, that also has some word problems. Because I think you need to focus on word problems, to be honest. All right? That'll come your way as well.